Our team name was the Oreo Rockets, consisting of Colin Galuzzo and Adam Herman. We chose this image because it best represents how our team communicated. Most of our project's planning was done electronically. The goal of this project was to improve the flapping flyer by increasing the amount of time the flyer is in the air. We used engineering processes to identify and construct ways to improve the flapping flyer. The use of systems engineering was essential to our project because of the way it helped us to identify and meet our requirements. Plainly said, we wanted our copter to be easy to construct and operate. We wanted it to be able to be bought at a low price and to be an overall improvement over the original design. Our systems requirements analysis shows what our specific requirements are and how we're going to verify that requirements were met. For example, in SR4, we see that we wanted the baseline device to be able to stay in the air for 10 seconds or longer, and the methods by which that we were going to verify that was through testing it. This V diagram shows the progression of our design. First, we found our user requirements and decided what we wanted the end model to achieve. Next, we specifically laid out how we were going to measure our user requirements by identifying the system requirements. Then, we defined what each component had to consist of. Next, we looked at how we could improve each component to meet our system requirements. We decided that an improvement in the tail, an increased wing area, and new fabrication instructions, and a longer body would help us to achieve our end goals. Then we defined how we were going to verify that our components and system were an improvement over the initial design. Our baseline model ran into a few issues. A major issue being that while transporting the flyer, a gust of wind destroyed the tail before we could fly time trials. After we repaired the tail, we had successful test flights with our longest being around 9 seconds. We decided that in order to improve the design, that we needed to strengthen the joints, especially the joints in the tail, and in order to get more flight time, we decided to increase wing area and double the propulsion by adding another rubber band. These images represent the original design and our design being on the right and the original design being on the left. There are two major differences between the original design and ours. Ours has a 1/2 inch extension of the body and has another rubber band added to the propulsion system. A minor difference between the two was ours lost about 1/8 of an inch on either wing. These flight test results show the remarkable difference between our flyer and the original flyer. Our flyer had an average time less than half of the original, and we believe that was due to the model consistently flying into the ground. We learned 3 major lessons with this ornithopter. We learned that it's important to transport carefully as the elements can easily destroy them, and that meetings don't always have to be in person. Most of the collaboration we did was online. And thirdly, systems engineering is extremely useful for designing and building an improvement of an existing system, despite the fact that ours didn't have that.